Good afternoon, students. So today we will discuss what is electric heating and what are its various types and what are the various methods to achieve electric heating. Now, before starting of that, I just want to discuss that regarding what are the various advantages. Due to that, we will prefer to heat any of the substance with the help of electric heating instead of that conventional heating method, or any other type of the heating method. So I will just discuss some of the advantages. First advantage is it is economical. First advantage is it is economical. We will discuss it one by one. So as far as economy is concerned, electrical heating is economical as electric. In this case, we are using electrical furnaces, and electrical furnaces are cheaper in initial cost as well as maintenance cost. So, and the second thing is it doesn't require any attention. So there are considerable saving in labor cost over the other type of the method, right? And electrical energy is also very cheap as it is being produced on a large scale. So if you consider all these factors, you will find that it will be comparatively economy to use this electric heating instead of other types of the conventional heating system. So first of all, this is the system which is economic with respect to, in comparison with other types of the system, right? So here in this case, why we saying that these are economic? Because cost of this electric furnace, cost of the electric furnace is comparatively less. And second thing is that it need less maintenance. So that means it is again economic if we are talking about in terms of maintenance and initial cost. And then if we are comparing, because we are comparing it with the starting that conventional type of the heating method, in that case we will have to check whether that fire is there or not again and again in case of conventional method, but in this case there is no such requirement, right? So that means labor cost is comparatively less. And another thing is this electrical energy, cost of the electrical energy, that is also comparatively cheaper. So due to this reason, we are saying that this electric heating is comparatively economic or cheaper in comparison with the other type of the heating method. Then after that, second method is that cleanliness. Cleanliness. So in case of this electrical heating, there is no ash, there is no dust, these are totally eliminated. In case of electric heating, there is no ash, there is no that dust. So that means what we are saying that this will be a clean source of energy. It is a clean system and cleaning cost is rendered to a minimum, because in other cases we need some again labor to transport ash, right? Then after that, in case of ordinary, that means this traditional type of the heating, there will be some flue gases which will affect the environmental conditions also, right? Because in case of electrical, there is no flue gas is absorbed in the system, so there is no risk of atmosphere or objects being heated and operation is, and therefore we may say that this electric heating is hygienic. Electrical heating is hygienic. Now next is ease of control. Ease of control. In case of again conventional heating, it is very difficult to control the temperature of the output. Let us say we want to heat some object or some substance with the help of a furnace. We will put that furnace on the some conventional either wood or some biogas or other type of the material, right? In that case, it is very difficult to control the temperature of that furnace, because till the time we are heating it, the temperature of the furnace is just going to be increased, right? So what will happen in case of this electrical heating system? We will be able to control the temperature. Even some heating elements are there, or some thermostats are there, which we may utilize to set the temperature. For example, if I am taking that example of iron press, in that particular case, if we want to iron silk cloth, temperature required is somewhat different. If we need to iron some other type cotton cloth, then the temperature required is somewhat different. So depending upon the temperature, we are having different temperature control with the help of some regulator, right? With the help of some regulator, we will be able to control that temperature. So similarly, in case of furnace, if we want to heat some specific chemical or some specific material which will be required to be heat up at a temperature of 500 degrees C, then in that case we will use such type of the metal or such type of the alloys Yes. So if I'm just taking that, I am just discussing that example of the iron. If I want to iron silk cloth, then temperature requirement is different. If I want to iron some other type of the cloth, then temperature requirement is somewhat different. So depending upon the requirement, depending upon the type of cloth, we may set that temperature of the iron, we may set that temperature of the iron with the help of that regulator. So that means in case of electric heating, we are having ease of control. Again, I am discussing one more example. That means in case of furnace, if I want to heat some specific substance, then in that particular case, let us say temperature requirement is 500 degrees C. So I may utilize some specific wire or material who will just cut off when temperature will reach up to 500 degrees C. There is a thermostat which is also available, which will cut your supply whenever temperature will reach up to that particular point. So due to this, that means in one line, in nutshell, but we are saying that there is a ease of control of the temperature in case of electric heating system, right? Then after that, next is automatic protection. Fifth advantage is automatic protection. So in case automatic protection against overcurrent or overheating can be provided through suitable switchgear in case of electric heating system, right? In case of electric heating system, we may provide that this protection against overcurrent or overheating by using this automatic protection system, by using some of the special type of the switchgear, right? Then after that, next is upper limit of the temperature. Upper limit of temperature. Now in case of electric heating system, there will be no upper limit of the temperature. There will be no upper limit to temperature obtainable except the availability of the material, to withstand that temperature. Let us say if we want to heat up to a temperature of, let us say, 5000 degrees C, then only limitation is your element will be capable to withstand that 5000 degrees C. If that element is capable to withstand at in the same state, that means it will not melt at a temperature of 5000 degrees C, then it's sufficient. No other condition is there, right? So in case of electric heating, this is again one of the great advantage, that there will be no upper limit of the temperature if material is present to withstand that temperature. Then after that, another is that better working condition, better
Sir,
working, just a minute, better working condition. Next is better working condition. So working condition plays a very important role. Working condition plays very important role in any of the output of any system. So in case of electric heating system, it will produce no irritation noise, and also radiating losses are low, right? So therefore working with the electric furnace is comparatively low, comparatively convenient and cool. In case of electric furnace, there will be no irritation, right? Or there will be no noise. Due to these reason, we are saying that this type of the furnaces more are having more better working condition in comparison with the ordinary condition, ordinary conventional type of the heating. Now next is high efficiency of utilization. Next advantage is high efficiency of utilization. High efficiency of utilization. Now, in case the overall efficiency of the electrical heating system is comparatively higher, overall efficiency of the electric heating system is overall comparatively higher, because in this system the source can be brought directly to the point where heat is required, right? And in that case what will happen? Losses will reduce. Losses will reduce. Further, there is no product of combustion in which heat losses are involved, right? So that means practically 75 to 100% of the heat produced by the electric heating can be successfully utilized, whereas in case of gas or solid fuel or oil heating, the effectiveness is about 60%. In case of gas, 30% in case of solid, and again 60% in case of this oil type. In case of, there are three types. One is solid, another is oil, another is gas, another is electrical, right? In case of electrical energy, efficiency will be 75 to 100%. Efficiency will be 75 to 100%. Whereas in case of solid and oil, the efficiency will be approximately 60% in both of the cases. Whereas in case of gas, In case of gas, this efficiency will reduce even up to 30%. So see comparison among conventional and this electrical heating system. In case of electrical heating system, efficiency will move up to 75 to 100%. Whereas in case of conventional type of the system, in case of conventional type of the system, there will be efficiency is comparatively very less, 30% to 60% only, right? 30% to 60% only. So that's why this, because there will be no losses, we will be moved directly on that point where heating is required. Heat losses are comparatively less. So due to this, the losses will be, if losses will be less, then efficiency of the system will be high. So due to this reason, what we are saying that in case of electrical system, there is high efficiency of utilization, right? Yes, now in case of this electrical heating system, there are some specific requirements like uniform heating of the material or heating of one particular portion of the job without affecting the other, or heating of the non-conducting material, heating with no oxidation. This can be met only in case of electrical heating system. So in case of electrical heating system, we will be capable to heat even some specific portion of the material without affecting the other, or we will be able to just make that material for the uniform heating, or with we want to heat some non-conducting material that may be also feasible with the help of electrical heating system. So these are some special cases are there which may be heat up with the help of electrical heating system. So that means electrical heating also satisfies special heating requirement, right? And safety is also there in case of electrical heating. Electrical heating is safe and responds quickly, right? So these are some of the advantages of electrical heating system. So due to these advantages, we prefer to use electrical heating system in comparison with other type of the heating system, in comparison with other types of the heating system, if electrical supply is available, right? If electrical supply is available, then we will prefer to use electrical heating system. Then after that, next is modes of electric heating. Modes of electric heating As usual, there are three modes of electric heating system. There are three modes of electrical heating system. First is conduction, second convection, and third conduction, convection, and radiation. Right? Conduction, first conduction, then second convection, and third radiation. You must studied all these types in your previous classes: conduction, convection, and radiation. So in case of conduction, that heat will be given by Q is equal to, in case of conduction, heat will be given by Q is equal to Ka upon T, Ka upon T into T1 minus T2, T1 minus T2T. So here, in this case, small t, this is the thickness of the plate in meter, thickness of the plate. T is equal to thickness of the plate which is required to be heat up in meter. Then after that, K is coefficient of thermal conductivity. K, this is the coefficient of thermal conductivity. Then A is that area of cross section. A is area of cross section, and T1 and T2. A is area of cross section. T1 and T2 are temperature of its two faces, absolute, the quantity of heat passed through it during T hours. Right? Now again, I think there is some sound problem. So in case small t, this is the thickness of the plate. A area of cross section, T1 and T2. These are the temperature of the two plates. K, coefficient of thermal conductivity. This is different for different material depending upon the material used. K is having different value. And capital T, this is the time in hours. Time in hours. Again, I am repeating. Q is equal to Ka. Q is equal to Ka. Now, in case of second category, that means in case of convection, output heat dissipation, this is given by H is equal to 3.875. H is equal to 3.875 into T1 minus T2 base to power T1 minus T2 base to power 1.25 watt per meter square. This is the heat dissipation in case of convection type of the heating. In case of convection type of the heating, this may be given by heat dissipation, may be given by H is equal to 3.875 into T1 minus T2 raised to power 1.25. And in case of radiation, the output heat dissipation is given by heat dissipation is given in case of radiation. In case of this heat dissipation is given by H is equal to 3.875 T1 minus T2 raised to power 1.25 watt per meter square. And in case of radiation, heat is given by H is equal to 5.72. H is equal to 5.72 into 10 raised to power 4. 5.72 into 10 raised to power 4 Ke into T1 upon 1000 base T1 base to power 4 minus T2 upon 1000 base to power 4 T1 upon 1000 base to power 4 minus T2 upon 1000 base to power 4 watt per meter square. So this is the relation. If we want to transfer the heat by the mode of radiation, this is for radiation, then this is the relation in case of convection, and this is the relation in case of conduction. So in this case, all that terms are having its meaning T1 is the temperature of the source of heat, T2 is the temperature of substance to be heated, both are in degree C. K, this is the constant known as radiant efficiency. K, here this K is unity for a single element and between 0.5 to 0.8 for several elements placed side by side. And E, small e, this is the emissivity, which is unity for black body, and this will vary between 0 to 0.9 for resistance heating elements, right? So this is the relation given by Stephen. This is the relation given by Stephen, and that's why this is known as the Stephen relation of radiation. Stephen relation of radiation. So in case of convection, H is equal to 3.875 into T1 minus T2 watt per meter square. Similarly, in case of radiation, H is equal to 5.72 into KE T1 upon 1000 raised to power 4 minus T2 upon 1000 raised to power 4 watt per meter square. So these are the relation in addition to basic of that conduction, convection and radiation for its mode of transfer of the heat. These relation are useful, right? This is the end of the lecture.
Excuse me.
So this is the end of the lecture. We will meet in next lecture again. Thank you.